Okay, magandang araw po. Let's solve another sample problem regarding effective stresses of stratified soil sample. Okay, we have here a soil profile is shown in the figure below. So, nire-draw lang po natin dito yung ating figure para mas malinaw po yung mga given parameters natin. Okay, we have a zone of capillary rise 2.5 meters in thickness on the sand layer. In that zone, the average degree of saturation is 60%. And we are required to compute these three unknown parameters. First one is the effective stress right below point B. Second, the effective stress of point C or at point C. And the last one is the effective stress at point D. Okay, first one, para makuha po natin yung mga unknown natin is to compute first the unit weights of the layers of the soil. So we have here three layers of soil, the dry sand, the zone of capillary rise layer, and the clay layer. So we have to compute first their respective unit weights. So ano yung ating i-compute na unit weight dahil marami po tayong klase ng unit weight. Okay, first one. For this layer, it says here dry sand. So we have to compute for the value of gamma dry for this layer of soil. And for the zone of capillary rise, the degree of saturation is given. That is not fully saturated. That means it is a moist layer soil. Ibig sabihin, we have to compute for its wet unit weight or moist unit weight or simply unit weight. And for the clay layer of soil, since nandito yung water table natin, the clay layer is below water table. If it is below water table, we have to compute for its saturated unit weight. So for this layer, compute for gamma dry. For this layer, compute for gamma moist. For this layer, compute for saturated unit weight. Okay, let's solve one by one. First one, gamma dry. What is the formula for gamma dry? We already discussed that in our first topic regarding properties of soil. And gamma dry is GS, unit weight of water, over 1 plus E. So substituting now, we have here specific gravity of the solid particles for that layer of soil and its void ratio of soil. Unit weight of water, that is constant. So substituting, this is 2.66 times 9.81, 1 plus 0.50. So computing for gamma dry, we will get a value of 17.3964 kilonewton per cubic meter. Okay, next one for the moist unit weight of the zone of capillary rise layer. So gamma moist is equivalent to, the formula is GS plus SE over 1 plus E multiplied by the unit weight of water. So substituting now, you will get, or substituting, GS is 2.71 plus degree of saturation 0.6 multiplied by 0.75 over 1 plus 0.75 multiplied by 9.81 kilonewton per cubic meter. So what will be our moist unit weight? That will be 17.714 kilonewton per cubic meter. And then for the last layer of soil, saturated unit weight, gamma sat is equivalent to GS plus SE over 1 plus E multiplied by unit weight of water, but saturated unit weight is equivalent to 1. So, the formula for saturated unit weight is GS plus E over 1 plus E multiplied by unit weight of water. Okay, substituting now, that will be equivalent to 2.72 plus E 0.95 over 1 plus void ratio of the last layer of soil, 0.95 multiplied by 9.81. So, calculating for saturated unit weight, this is 18.463 kilonewtons per cubic meter. Okay, kapag na-compute na po natin yung ating mga unit weights, we are now ready to compute for the effective stresses. And we know that effective stress is equivalent to total stress. Say that is, we are taking consideration point C. Or for the first unknown first, point B, effective stress of point B is equivalent to the total stress at that point minus the water pressure at that point. Okay, so for the point B, that is the junction of the dry sand and then the zone of capillary rise. That could be the lower point of dry sand and the upper point of the zone of capillary rise. But, sinabi sa problem, effective stress right below point B. So, right below point B, it is considering the zone of capillary rise. So, ibig sabihin, ano mismo yung effective stress at point B or right below point B, which is the zone of capillary rise. So, compute the total stress at that point and then the water pressure at that point. First one, compute the total stress right below point B. So, for the total stress from the ground surface up to point B, we are considering one layer of soil. And we know that total stress is just a product of the unit weight of the soil layer multiplied by the thickness of the soil layer. So, that will be equivalent to gamma dry 17.3964 multiplied by the thickness 4 meters. So, total stress is equivalent to 69.5856 kilopascal. And then, for the water pressure at point B, right below point B, we will use the formula of water pressure regarding zone of capillary rise or the water pressure of capillary rise. Ano ba yung formula dun? That is negative pressure. Since pataas po mismo yun. Pag tumataas po tayo, that is a negative pressure. Pag bumaba po tayo, lumalaki yung value ng water pressure natin. Ibig sabihin, dapat nag-a-add tayo. So that is a positive. Since tumaas po, since rise, ibig sabihin, tumaas yung ating tubig. So the way is upward. So that is a negative pressure there. So negative multiplied by unit weight of water multiplied by the height of capillary rise within that point at point B multiplied by the degree of saturation of the capillary zone. So substituting, that is negative 9.81 multiplied by the height of capillary rise at point B. So this is our original groundwater table and it will rise up to point B. So the height of capillary rise is equivalent to 2.5 meters multiplied by the degree of saturation, that will be 60% or 0.6. So that will be equivalent to negative 14.715 kilopascal. So substituting now to our formula of effective stress, therefore, effective stress at point B or right below point B is equivalent to total stress 69.5856 minus water pressure at point B negative 14.715 kilopascal. That will be equivalent to 84.30 kilopascal. And that will be the value for the first unknown. Okay. Paano naman, this is dagdag lang na katanungan, paano naman pag sinabing effective stress or compute the effective stress right above point B? Pag sinabing right above point B, eto mismo yun. Ang kino-consider nun ay yung dry sand above point B. Ibig sabihin, yung formula natin ng water pressure ay hindi yung formula ng water pressure for the capillary rise. Yung as is lang. Yung walang degree of saturation. When that happens, so additional question, so effective stress at point B is equivalent to total stress at point B minus water pressure at point B. So that will be equivalent to total stress at point B from ground surface to point B. Parang kanina lang. The same dito. 69.5856 minus. Dito sila nag-iba. Sa water pressure at point B. Water pressure at point B, from this point to this point, wala pa tayong tubig na kino-consider. Since yung dry sand ang ating tinutukoy kapag sinabing right above point B. So since walang tubig na kino-consider, that is equivalent to 0. Since water pressure is the product of the unit weight of water and the height of water. Since there is no water, there will be no height of water, and that will be equivalent to 0. Therefore, the effective stress right above point B will be equivalent to the total stress, which is 69.5856 kilopascal. Okay, let's solve for the second unknown, the effective stress of point C. So, effective stress at point C is equivalent to total stress at point C minus water pressure at point C. If we can notice here, point C is the junction of the zone of capillary rise and the clay layer. So, pwede nyong gamitin yung formula ng zone of capillary rise or yung walang capillary rise, which is the clay layer. Maalin man doon, parehas lang po or mag-a-arrive po tayo sa parehas na sagot. Okay. Let's solve for that. So, para ma-solve to, solve first for these two parameters. For the total stress at point C, ito yung point C natin, total stress from the ground surface up to point C. So, we are considering two layers of soil. So, summation lang ng effective or total stress. So, that will be, for the first layer, gamma dry, 17.3964 multiplied by its thickness, 4 meters, plus gamma moist, 17.714 multiplied by its thickness, 2.5 meters. That will be the total stress at point C minus the water pressure at point C. So, consider natin mismo yung formula ng ating water pressure of capillary rise. And that will be negative unit weight of water, height of capillary rise, degree of saturation. So, that is minus negative 9.81 multiplied by the height of capillary rise. Nandito yung original water level natin. And then, aakyat daw siya kay point C. Yung kinoconsider natin. Therefore, the height of capillary rise at point C is 0. Dahil yung point C, nandun din sa ating water table. Multiplied by degree of saturation, that is 0.6. And that will be 0. So, computing for the effective stress at point C, that will be equivalent to 113.87 kilopascal. And then, solving for the last one, the effective stress at point D. So, effective stress at point D, that will be equivalent to total stress at point D minus water pressure at point D. Okay, so from the ground surface up to point D, we are considering 3 layers of soil now. So, that will be equivalent to 17.3964 multiplied by 4 meters plus second layer 17.714 times 2.5 plus third layer of soil 18.463 multiplied by the thickness 5 meters. That will be our total stress minus the water pressure at point D. So from the ground surface up to point D, water pressure is the product of the unit weight of water and the height of water. So from the ground surface up to point D, the height of water is 5 meters. So that will be minus 9.81 multiplied by a height of water which is 5 meters. So, computing for the effective stress at point D, we will get 157.136 kilopascal. And that will be the requirements for this given problem.